A gold processor has two sources of gold ore, source A and source B. In order to keep his plant running, at least 3 tons of ore must be processed each day. Ore from source A costs $20 per ton to process, and ore from source B costs $10 per ton to process. Costs must be kept to less than $80 per day. Moreover, federal regs require that the amount of ore from source B cannot exceed twice the amount of ore from source A. If ore from source A yields 2 ounces of gold per ton, and ore from source B yields 3 ounces of gold per ton, how many tons of ore from both sources must be processed each day to maximize the amount of gold extracted subject to the above constraints? So, to begin with, we need to define our variables. And I look at the question in order to give me a focus or get me the answer to what those variables should be. So it's asking you how many tons from both sources must be processed. So right there, I want to find out how many tons from source A and how many tons from source B do I need to process in order to maximize the amount of gold extracted. So we're going to let X represent or equal the number of tons of ore processed from source A. And we're going to let Y represent or equal the number of tons of ore processed from source B. Okay. Alright, so after we define the variables, now we need to start determining our constraints. Okay, so the first thing I'm going to look at is, in order to keep this plant running, at least 3 tons of ore must be processed each day. So if X and Y represent the total number of tons of processed ore, so their sum, X plus Y, this expression represents the number of processed tons, and they must have at least 3. So this has to be greater than or equal to 3 tons. Okay? All right. And they say here that ore from source A costs $20 per ton to process, and ore from source B costs $10 per ton to process, and costs must be less than $80 per day. So we can write, so this is an amount inequality. Now we can write a cost inequality, and we can say $20 per ton times X number of tons plus $10 per ton times Y number of tons must be kept to less than $80 a day. So less than $80. Where each of these represents a dollar amount. This is the total dollar amount for source A tons, and this is the dollar amount, total dollar amount for source B tons. Okay. Federal regulations indicates or require that the amount of source from the amount of ore from source B, that would be Y, cannot exceed, which means less than or equal to, twice the amount from source A, 2 times X. Okay? Alright? So those are inequalities, and of course X and Y both have to be greater than or equal to 0. Alright? So these are the inequalities that we're going to be working with. Alright? So we'll call, so we've now defined our variables, we've written the inequalities, and now we need to graph those inequalities. Okay? So, we're saying that the X is the number of tons from source A. And this is source B tons. Now let's go ahead and figure out our intercepts. So this one, if I let X be 0, so I'm going to, for this inequality right here, let's write that down here, X plus Y greater than or equal to 3. So if I let the X variable be 0, Y would be 3. And if I let the Y variable be 0, then X would be 3. So based off of these X and Y intercepts, 0, 3 is right here, and 3, 0 is here, and I would draw my line. Use my test point. So if I let the test point be 0, 0, and plug that in for X and Y, 0 plus 0 is 0. Is 0 greater than 3? The answer is no. So I would shade on this side of the line. Okay? So here I have 20x plus 10y less than 80. So if I let x be 0, so 10y equals 80, so y would be 8. And if I let y be 0, 20x equals 80, and if I divide both sides by 20, I get x equals 4. So I find 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. And I go 4, 0. 1, 2, 3, 4. Okay, and I draw my line. Oh, except that this line is incorrect because this is a dotted line. So I need to make that into a dotted line. So let's see here. And that's going to be shaded this direction. Okay? And then I have one more, and that is y less than or equal to 2x. Well, this would be so we'll go y less than or equal to 2x plus 0. So I'm going to go at 0, 0, and I'm up 2 over 1. Up 2 over 1. So I have a line now, a solid line, starting here at 0, 0. And if I pick, for instance, 1, 0, so 1, 0 as my test point, 0 less than or equal to 2 times 1 is 0 less than or equal to 2. The answer is yes. So I'm going to shade on this side of the line. So my common shaded region then is going to be this quadrilateral that you see in green right here. It's not shading very well, but you kind of get the idea. It's this area right here. Okay? So, after we have identified the feasible region, then we need to establish the vertices. And we're going to do that in our next film.